The Economy of Machinery and Manufactures by Charles Babbage 1832. Chapter 11. Of Copying. 82. The two last mentioned sources of excellence in the work produced by machinery depend on a principle which pervades a very large portion of all manufactures, and is one upon which the cheapness of the articles produced seems greatly to depend. The principle alluded to is that of copying, taken in its most extensive sense. Almost unlimited pains are, in some instances, bestowed on the original, from which a series of copies is to be produced, and the larger the number of these copies, the more care and pains can the manufacturer afford to lavish upon the original. It may thus happen, that the instrument or tool actually producing the work, shall cost 5 or even 10,000 times the price of each individual specimen of its power. As the system of copying is of so much importance, and of such extensive use in the arts, it will be convenient to classify a considerable number of those processes in which it is employed. The following enumeration, however, is not offered as a complete list, and the explanations are restricted to the shortest possible detail which is consistent with a due regard to making the subject intelligible. The operations of copying are effected under the following circumstances: by printing from cavities, by stamping, by printing from surface, by punching, by casting with elongation, by molding with altered dimensions. Of printing from cavities. 83. The art of printing, in all its numerous departments, is essentially an art of copying. Under its two great divisions, printing from hollow lines, as in copper plate, and printing from surface, as in block printing, are comprised numerous arts. 84. Copper plate printing. In this instance, the copies are made by transferring to paper, by means of pressure, the thick ink, from the hollows and lines cut in the copper. An artist will sometimes exhaust the labor of 1 or 2 years upon engraving the plate, which will not, in some cases, furnish above 500 copies in a state of perfection. 85. Engravings on steel. This art is like that of engraving on copper, except that the number of copies is far less limited. The banknote engraved as a copper plate will not give above 3,000 impressions without a sensible deterioration. 2 impressions of a banknote engraved on steel were examined by one of our most eminent artists, who found it difficult to pronounce with any confidence which was the earliest impression. One of these was a proof from amongst the first 1,000, the other was taken after between 70 and 80,000 had been printed off. 86. Music printing. Music is usually printed from pewter plates, on which the characters have been impressed by steel punches. The metal, being much softer than copper, is liable to scratches, which detain a small portion of the ink. This is the reason of the dirty appearance of printed music. A new process has recently been invented by Mr. Cooper, by which this inconvenience will be avoided. The improved method, which gives sharpness to the characters, is still an art of copying, but it is effected by surface printing, nearly in the same manner as calico printing from blocks, to be described hereafter. 96. The method of printing music from pewter plates, although by far the most frequently made use of, is not the only one employed, for music is occasionally printed from stone. Sometimes also it is printed with movable type, and occasionally the musical characters are printed on the paper, and the lines printed afterwards. Specimens of both these latter modes of music printing may be seen in the splendid collection of impressions from the types of the press of Babbage at Parma. But notwithstanding the great care bestowed on the execution of that work, the perpetual interruption of continuity in the lines, arising from the use of movable types, when the characters and lines are printed at the same time, is apparent. 87. Calico printing from cylinders. Many of the patterns on printed calicos are copies by printing from copper cylinders about 4 or 5 inches in diameter, on which the desired pattern has been previously engraved. One portion of the cylinders is exposed to the ink, whilst an elastic scraper of very thin steel, by being pressed forcibly against another part, removes all superfluous ink from the surface previously to its reaching the cloth. A piece of calico 28 yards in length rolls through this press, and is printed in 4 or 5 minutes. 88. Printing from perforated sheets of metal, or stenciling. Very thin brass is sometimes perforated in the form of letters, usually those of a name. This is placed on any substance which it is required to mark, and a brush dipped in some paint is passed over the brass. Those parts which are cut away admit the paint, and thus a copy of the name appears on the substance below. This method, which affords rather a coarse copy, is sometimes used for paper with which rooms are covered, and more especially for the borders. If a portion be required to match an old pattern, this is, perhaps, the most economical way of producing it. 89. Colored impressions of leaves upon paper may be made by a kind of surface printing. Such leaves are chosen as have considerable inequalities. The elevated parts of these are covered, by means of an inking ball, with a mixture of some pigment ground up in linseed oil. The leaf is then placed between two sheets of paper, and being gently pressed, the impression from the elevated parts on each side appear on the corresponding sheets of paper. 90. The beautiful red cotton handkerchiefs dyed at Glasgow have their pattern given to them by a process similar to stenciling, except that instead of printing from a pattern, the reverse operation, that of discharging a part of the color from a cloth already dyed, is performed. The number of handkerchiefs are pressed with very great force between two plates of metal, which are similarly perforated with round or lozenge-shaped holes, according to the intended pattern. The upper plate of metal is surrounded by a rim, and a fluid which has the property of discharging the red dye is poured upon that plate. This liquid passes through the holes in the metal, and also through the calico, but, owing to the great pressure opposite all the parts of the plates not cut away, it does not spread itself beyond the pattern. After this, the handkerchiefs are washed, and the pattern of each is a copy of the perforations in the metal plate used in the process. Another mode by which a pattern is formed by discharging color from a previously dyed cloth, is to print on it the pattern with paste. Then, passing it into the dyeing vat, it comes out dyed of one uniform color, but the paste has protected the fibers of the cotton from the action of the dye or mordant, and when the cloth so dyed is well washed, the paste is dissolved, and leaves uncolored all those parts of the cloth to which it was applied. Printing from surface. 91. This second department of printing is of more frequent application in the arts than that which has just been considered. 92. Printing from wooden blocks. The block of boxwood is, in this instance, the substance out of which the pattern is formed, the design being sketched upon it. The workman cuts away with sharp tools every part except the lines to be represented in the impression. This is exactly the reverse of the process of engraving on copper, in which every line to be represented is cut away. The ink, instead of filling the cavities cut in the wood, is spread upon the surface which remains, and is thence transferred to the paper. 93. Printing from movable types. This is the most important in its influence of all the arts of copying. It possesses a singular peculiarity, in the immense subdivision of the parts that form the pattern. After that pattern has furnished thousands of copies, the same individual elements may be arranged again and again in other forms, and thus supply multitudes of originals, from each of which thousands of their copied impressions may float. It also possesses this advantage, that woodcuts may be used along with the letterpress, and impressions taken from both at the same operation. 94. Printing from stereotype. This mode of producing copies is very similar to the preceding. There are two modes by which stereotype plates are produced. In that most generally adopted, a mold is taken in plaster from the movable types, and in this the stereotype plate is cast. Another method has been employed in France. Instead of composing the work in movable type, it was set up in movable copper matrices, each matrix being in fact a piece of copper of the same size as the type, and having the impression of the letter sunk into its surface, instead of projecting in relief. The stereotype plate may, it is evident, be obtained at once from this arrangement of matrices. The objection to the plan is the great expense of keeping so large a collection of matrices. As the original composition does not readily admit of change, stereotype plates can only be applied with advantage to cases where an extraordinary number of copies are demanded, or where the work consists of figures, and it is of great importance to ensure accuracy. Trifling alterations may, however, be made in it from time to time, and thus mathematical tables may, by the gradual extirpation of error, at last become perfect. This mode of producing copies possesses, in common with that by movable types, the advantage of admitting the use of woodcuts, the copy of the woodcut in the stereotype plate being equally perfect with that of the movable type. This union is of considerable importance, and cannot be accomplished with engravings on copper. 95. Lettering books. The gilt letters on the backs of books are formed by placing the piece of gold leaf upon the leather, and pressing upon it brass letters previously heated. These cause the gold immediately under them to adhere to the leather, whilst the rest of the metal is easily brushed away. When a great number of copies of the same volume are to be lettered, it is found to be cheaper to have a brass pattern cut with the whole of the proper title. This is placed in a press, and being kept hot, the covers, each having a small bit of leaf gold placed in the proper position, were successively brought under the brass, and stamped. The lettering at the back of the volume in the reader's hand was executed in this manner. 96. Calico printing from blocks. This is a mode of copying, by surface printing, from the ends of small pieces of copper wire, of various forms, fixed into a block of wood. They are all of one uniform height, about the eighth part of an inch above the surface of the wood, and are arranged by the maker into any required pattern. If the block be placed upon a piece of fine woolen cloth, on which ink of any color has been uniformly spread, the projecting copper wires receive a portion, which they give up when applied to the calico to be printed. By the former method of printing on calico, only one color could be used, but by this plan, after the flower of the rose, for example, has been printed with one set of blocks, the leaves may be printed of another color by a different set. 97. Printing oilcloth. After the canvas, which forms the basis of oilcloth, has been covered with paint of one uniform tint, the remainder of the processes which it passes through, are a series of copyings by surface printing, from patterns formed upon wooden blocks very similar to those employed by the calico printer, each color requiring a distinct set of blocks. Those oilcloths with the greatest variety of colors are most expensive. There are several other varieties of printing which we shall briefly notice as arts of copying, which, although not strictly surface printing, yet are more allied to it than that from copper plates. 98. Letter copying. In one of the modes of performing this process, a sheet of very thin paper is damped, and placed upon the writing to be copied. The two papers are then passed through a rolling press, and a portion of the ink from one paper is transferred to the other. The writing is, of course, reversed by this process, but the paper to which it is transferred being thin, the characters are seen through it on the other side, in their proper position. Another common mode of copying letters is by placing a sheet of paper covered on both sides with a substance prepared from lamp black, between the sheet of thin paper and the paper on which the letter to be dispatched is to be written. If the upper or thin sheet be written upon with any hard pointed substance, the word written with this style will be impressed from the black paper upon both those adjoining it. The translucency of the upper sheet, which is retained by the writer, is in this instance necessary to render legible the writing which is on the back of the paper. Both these arts are very limited in their extent, the former affording 2 or 3, the latter from 2 to perhaps 10 or 15 copies at the same time. 99. Printing on china. This is an art of copying which is carried to a very great extent. As the surfaces to which the impression is to be conveyed are often curved, and sometimes even fluid, the ink, or paint, is first transferred from the copper to some flexible substance, such as paper, or an elastic compound of glue and treacle. It is almost immediately conveyed from this to the unbaked biscuit, to which it more readily adheres. 100. Lithographic printing. This is another mode of producing copies in almost unlimited number. The original which supplies the copies is a drawing made on a stone of a slightly porous nature. The ink employed for tracing it is made of such greasy materials that when water is poured over the stone it shall not wet the lines of the drawing. When a roller covered with printing ink, which is of an oily nature, is passed over the stone previously wetted, the water prevents this ink from adhering to the uncovered portions, whilst the ink used in the drawing is of such a nature that the printing ink adheres to it. In this state, if a sheet of paper be placed upon the stone, and then passed under a press, the printing ink will be transferred to the paper, leaving the ink used in the drawing still adhering to the stone. 101. There is one application of lithographic printing which does not appear to have received sufficient attention, and perhaps further experiments are necessary to bring it to perfection. It is the reprinting of works which have just arrived from other countries. A few years ago one of the Paris newspapers was reprinted at Brussels as soon as it arrived by means of lithography. Whilst the ink is yet fresh, this may easily be accomplished. It is only necessary to place one copy of the newspaper on a lithographic stone, and by means of great pressure applied to it in a rolling press, a sufficient quantity of the printing ink will be transferred to the stone. By similar means, the other side of the newspaper may be copied on another stone, and these stones will then furnish impressions in the usual way. If printing from stone could be reduced to the same price per thousand as that from movable types, this process might be adopted with great advantage for the supply of works for the use of distant countries possessing the same language. For a single copy might be printed off with transfer ink, and thus an English work, for example, might be published in America from stone, whilst the original, printed from movable types, made its appearance on the same day in England. 102. It is much to be wished that such a method were applicable to the reprinting of facsimiles of old and scarce books. This, however, would require the sacrifice of 2 copies, since a leaf must be destroyed for each page. Such a method of reproducing a small impression of an old work is peculiarly applicable to mathematical tables, the setting up of which in type is always expensive and liable to error. But how long ink will continue to be transferable to stone, from paper on which it has been printed, must be determined by experiment. The destruction of the greasy or oily portion of the ink in the character of old books, seems to present the greatest impediment. If one constituent only of the ink were removed by time, it might perhaps be hoped that chemical means would ultimately be discovered for restoring it, but, if this be unsuccessful, an attempt might be made to discover some substance having a strong affinity for the carbon of the ink which remains on the paper, and very little for the paper itself. To * 103. Lithographic prints have occasionally been executed in colors. In such instances a separate stone seems to have been required for each color, and considerable care, or very good mechanism, must have been employed to adjust the paper to each stone. If any 2 kinds of ink should be discovered mutually inadhesive, 1 stone might be employed for 2 inks, or if the inking roller for the second and subsequent colors had portions cut away corresponding to those parts of the stone inked by the previous ones, then several colors might be printed from the same stone, but these principles do not appear to promise much, except for coarse subjects. 104. Register printing. It is sometimes thought necessary to print from a wooden block, or stereotype plate, the same pattern reversed upon the opposite side of the paper. The effect of this, which is technically called register printing, is to make it appear as if the ink had penetrated through the paper, and rendered the pattern visible on the other side. If the subject chosen contains many fine lines, it seems at first sight extremely difficult to effect so exact a superposition of the 2 patterns, on opposite sides of the same piece of paper, that it shall be impossible to detect the slightest deviation, yet the process is extremely simple. The block which gives the impression is always accurately brought down to the same place by means of a hinge. This spot is covered by a piece of thin leather stretched over it. The block is now inked, and being brought down to its place, gives an impression of the pattern to the leather. It is then turned back, and being inked a second time, the paper intended to be printed is placed upon the leather. When the block again descending, the upper surface of the paper is printed from the block, and its undersurface takes up the impression from the leather. It is evident that the perfection of this mode of printing depends in a great measure on finding some soft substance like leather, which will take as much ink as it ought from the block, and which will give it up most completely to paper. Impressions thus obtained are usually fainter on the lower side, and in order in some measure to remedy this defect, rather more ink is put on the block at the first than at the second impression. Of copying by casting. 105. The art of casting, by pouring substances in a fluid state into a wood which retains them until they become solid, is essentially an art of copying, the form of the thing produced depending entirely upon that of the pattern from which it was formed. 106. Of casting iron and other metals. Patterns of wood or metal made from drawings are the originals from which the molds for casting are made, so that, in fact, the casting itself is a copy of the mold, and the mold is a copy of the pattern. In castings of iron and metals for the coarser purposes, and, if they are afterwards to be worked, even for the finer machines, the exact resemblance amongst the things produced, which takes place in many of the arts to which we have alluded, is not effected in the first instance, nor is this necessary. As the metals shrink in cooling, the pattern is made larger than the intended copy, and in extricating it from the sand in which it is molded, some little difference will occur in the size of the cavity which it leaves. In smaller works, where accuracy is more requisite, and where few or no after operations are to be performed, the mold of metal is employed which has been formed with considerable care. Thus, in casting bullets, which ought to be perfectly spherical and smooth, an iron instrument is used, in which a cavity has been cut and carefully ground, and, in order to obviate the contraction in cooling, a jet is left which may supply the deficiency of metal arising from that cause, and which is afterwards cut off. The leaden toys for children are cast in brass molds which open, and in which have been graved or chiseled the figures intended to be produced. 107. The very beautiful mode of representing small branches of the most delicate vegetable productions in bronze has been employed by Mr. Chancery. A small strip of a fir tree, a branch of holly, a curled leaf of broccoli, or any other vegetable production, is suspended by one end in a small cylinder of paper which is placed for support within a similarly formed tin case. The finest river silk, carefully separated from all the coarser particles, and mixed with water, so as to have the consistency of cream, is poured into the paper cylinder by small portions at a time, carefully shaking the plant a little after each addition, in order that its leaves may be covered, and that no bubbles of air may be left. The plant and its mold are now allowed to dry, and the yielding nature of the paper allows the loamy coating to shrink from the outside. When this is dry it is surrounded by a coarser substance, and, finally, we have the twig with all its leaves embedded in a perfect mold. This mold is carefully dried, and then gradually heated to a red heat. At the ends of some of the leaves or shoots, wires have been left to afford air holes by their removal, and in this state of strong ignition a stream of air is directed into the hole formed by the end of the branch. The consequence is, that the wood and leaves which had been turned into charcoal by the fire, are now converted into carbonic acid by the current of air, and, after some time, the whole of the solid matter of which the plant consisted is completely removed, leaving a hollow mold, bearing on its interior all the minutest traces of its late vegetable occupant. When this process is completed, the mold being still kept at nearly a red heat, receive the fluid metal, which, by its weight, either drives the very small quantities of air, which at that high temperature remains behind, out very through the air holes, or compresses it into the pores of very porous substance of which the mold is formed. 108. When the form of the object intended to be cast is such that the pattern cannot be extricated from its mold of sand or plaster, it becomes necessary to make the pattern with wax, or some other easily fusible substance. The sand or plaster is molded round this pattern, and, by the application of heat, the wax is extricated through an opening left purposely for its escape. 109. It is often desirable to ascertain the form of the internal cavities, inhabited by molluscous animals, such as those of spiral shells, and the various corals. This may be accomplished by filling them with fusible metal, and dissolving the substance of the shell by muriatic acid. Thus a metallic solid will remain which exactly filled all the cavities. If such forms are required in silver, or any other difficulty fusible metal, the shells may be filled with wax or resin, then dissolved away, and the remaining waxen form may serve as the pattern from which a plaster mold may be made for casting the metal. Some nicety will be required in these operations, and perhaps the minuter cavities can only be filled under an exhausted receiver. 110. Casting in plaster. This is a mode of copying applied to a variety of purposes, to produce accurate representations of the human form, of statues, or of rare fossils, to which latter purpose it has lately been applied with great advantage. In all casting, the first process is to make the mold, and plaster is the substance which is almost always employed for the purpose. The property which it possesses of remaining for a short time in a state of fluidity, renders it admirably adapted to this object, and adhesion, even to an original of plaster, is effectually prevented by oiling the surface on which it is poured. The mold formed round the subject which is copied, removed in separate pieces and then reunited, is that in which the copy is cast. This process gives additional utility and value to the finest works of art. The students of the Academy at Venice are thus enabled to admire the sculptured figures of Aegina, preserved in the gallery at Munich, as well as the marbles of the Parthenon, the pride of our own museum. Casts in plaster of the Elgin marbles adorn many of the academies of the continent, and the liberal employment of such presents affords us an inexpensive and permanent source of popularity. 111. Casting in wax. This mode of copying, aided by proper coloring, offers the most successful imitations of many objects of natural history, and gives an air of reality to them which might deceive even the most instructed. Numerous figures of remarkable persons, having the face and hands formed in wax, have been exhibited at various times, and the resemblances have, in some instances, been most striking. But whoever would see the art of copying in wax carried to the highest perfection, should examine the beautiful collection of fruit at the house of the Horticultural Society. The model of the magnificent flower of the new genus Rafflesia, the waxen models of the internal parts of the human body which adorn the anatomical gallery of the Jardin des Plantes at Paris, and the museum at Florence, or the collection of morbid anatomy at the University of Bologna. The art of imitation by wax does not usually afford the multitude of copies which flow from many similar operations. This number is checked by the subsequent stages of the process, which, ceasing to have the character of copying by a tool or pattern, become consequently more expensive. In each individual production, form alone is given by casting. The coloring must be the work of the pencil, guided by the skill of the artist. Of copying by molding. 112. This method of producing multitudes of individuals having an exact resemblance to each other in external shape, is adopted very widely in the arts. The substances employed are, either naturally or by artificial preparation, in a soft or plastic state. They are then compressed by mechanical force, sometimes assisted by heat, into a mold of the required form. 113. Of bricks and tiles. An oblong box of wood fitting upon the bottom fixed to the brickmaker's bench, is the mold from which every brick is formed. A portion of the plastic mixture of which the bricks consist is made ready by less skillful hands. The workman first sprinkles a little sand into the mold, and then throws the clay into it with some force, at the same time rapidly working it with his fingers, so as to make it completely close up to the corners. He next scrapes off, with a wetted stick, the superfluous clay, and shakes the new formed brick dexterously out of its mold on a piece of board, on which it is removed by another workman to the place appointed for drying it. A very skillful molder has occasionally, in a long summer's day, delivered from 10 to 11,000 bricks, but a fair average day's work is from 5 to 6,000. Tiles of various kinds and forms are made of finer materials, but by the same system of molding. Among the ruins of the city of Gort, the ancient capital of Bengal, bricks are found having projecting ornaments in high relief. These appear to have been formed in a mold, and subsequently glazed with a colored glaze. In Germany, also, brickwork has been executed with various ornaments. The cornice of the Church of St. Stefano, at Berlin, is made of large blocks of brick molded into the form required by the architect. At the establishment of Messrs. Cubitt, in Gray's Inn Lane, vases, cornices, and highly ornamented capitals of columns are thus formed which rival stone itself in elasticity, hardness, and durability. 114. Of embossed china. Many of the forms given to those beautiful specimens of earthenware which constitute the equipage of our breakfast and our dinner tables, cannot be executed in the lathe of the potter. The embossed ornaments on the edges of the plates, their polygonal shape, the fluted surface of many of the vases, would all be difficult and costly of execution by the hand, but they become easy and comparatively cheap, when made by pressing the soft material out of which they are formed into a hard mold. The care and skill bestowed on the preparation of that mold are repaid by the multitude it produces. In many of the works of the China manufactory, one part only of the article is molded, the upper surface of the plate, for example, whilst the underside is figured by the lathe. In some instances, the handle, or only a few ornaments, are molded, and the body of the work is turned. 115. Glass seals. The process of engraving upon gems requires considerable time and skill. The seals thus produced can therefore never become common. Imitations, however, have been made of various degrees of resemblance. The color which is given to glass is, perhaps, the most successful part of the imitation. A small cylindrical rod of colored glass is heated in the flame of a blowpipe, until the extremity becomes soft. The operator then pinches it between the ends of a pair of nippers, which are formed of brass, and on one side of which the device intended for the seal has been carved in relief. When the mold has been well finished and care is taken in heating the glass properly, the seals thus produced are not bad imitations, and by this system of copying they are so multiplied, that the more ordinary kinds are sold at Birmingham for 3d. a dozen. 116. Square glass bottles. The round forms which are usually given to vessels of glass are readily produced by the expansion of the air with which they are blown. It is, however, necessary in many cases to make bottles of a square form, and each capable of holding exactly the same quantity of fluid. It is also frequently desirable to have imprinted on them the name of the maker of the medicine or other liquid they are destined to contain. The mold of iron, or of copper, is provided of the intended size, on the inside of which are engraved the names required. This mold, which is used in a hot state, opens into two parts, to allow the insertion of the round, unfinished bottle, which is placed in it in a very soft state before it is removed from the end of the iron tube with which it was blown. The mold is now closed, and the glass is forced against its sides, by blowing strongly into the bottle. 117. Wooden snuff boxes. Snuff boxes ornamented with devices, in imitation of carved work or of rose engine turning, are sold at a price which proves that they are only imitations. The wood, or horn, out of which they are formed, is softened by long boiling in water, and whilst in this state it is forced into molds of iron, or steel, on which are cut the requisite patterns, where it remains exposed to great pressure until it is dry. 118. Horn knife handles and umbrella handles. The property which horn possesses of becoming soft by the action of water and of heat, fits it for many useful purposes. It is pressed into molds, and becomes embossed with figures in relief, adapted to the objects to which it is to be applied. If curved, it may be straightened, or if straight, it may be bent into any forms which ornament or utility may require, and by the use of the mold these forms may be multiplied in endless variety. The commoner sorts of knives, the crooked handles for umbrellas, and a multitude of other articles to which horn is applied, attest the cheapness which the art of copying gives to the things formed of this material. 119. Molding tortoise shell. The same principle is applied to things formed out of the shell of the turtle, or the land tortoise. From the greatly superior price of the raw material, this principle of copying is, however, more rarely employed upon it, and the few carvings which are demanded, are usually performed by hand. 120. Tobacco pipe making. This simple art is almost entirely one of copying. The molds are formed of iron, in two parts, each embracing one half of the stem. The line of junction of these parts may generally be observed running lengthwise from one end of the pipe to the other. The hole passing to the bowl is formed by thrusting a long wire through the clay before it is enclosed in the mold. Some of the molds have figures, or names, sunk in the inside, which give a corresponding figure in relief upon the finished pipe. 121. Embossing upon calico. Calicos of one color, but embossed all over with raised patterns, though not much worn in this country, are in great demand in several foreign markets. This appearance is produced by passing them between rollers, on one of which is figured in intaglio the pattern to be transferred to the calico. The substance of the cloth is pressed very forcibly into the cavities thus formed, and retains its pattern after considerable use. The watered appearance in the cover of the volume in the reader's hands is produced in a similar manner. A cylinder of gun metal, on which the design of the watering is previously cut, is pressed by screws against another cylinder, formed out of pieces of brown paper which have been strongly compressed together and accurately turned. The two cylinders are made to revolve rapidly, the paper one being slightly damped, and, after a few minutes, it takes an impression from the upper or metal one. The glazed calico is now passed between the rollers, its glossy surface being in contact with the metal cylinder, which is kept hot by a heated iron enclosed within it. Calicos are sometimes watered by placing two pieces on each other in such a position that the longitudinal threads of the one are at right angles to those of the other, and compressing them in this state between flat rollers. The threads of the one piece produce indentations in those of the other, but they are not so deep as when produced by the former method. 122. Embossing upon leather. This art of copying from patterns previously engraved on steel rollers is in most respects similar to the preceding. The leather is forced into the cavities, and the parts which are not opposite to any cavity are powerfully condensed between the rollers. 123. Swaging. This is an art of copying practiced by the smith. In order to fashion his iron and steel into the various forms demanded by his customers, he has small blocks of steel into which are sunk cavities of different shapes. These are called swages, and are generally in pairs. Thus if he wants a round bolt, terminating in a cylindrical head of larger diameter, and having one or more projecting rims, he uses a corresponding swaging tool, and having heated the end of his iron rod, and thickened it by striking the end in the direction of the axis, which is technically called upsetting, he places its head upon one part of the lathe, and whilst an assistant holds the other part on the top of the hot iron, he strikes it several times with his hammer, occasionally turning the head 1/4 round. The heated iron is thus forced by the blows to assume the form of the mold into which it is impressed. 124. Engraving by pressure. This is one of the most beautiful examples of the art of copying carried to an almost unlimited extent, and the delicacy with which it can be executed, and the precision with which the finest traces of the graving tool can be transferred from steel to copper, or even from hard steel to soft steel, is most unexpected. We are indebted to Mr. Perkins for most of the contrivances which have brought this art at once almost to perfection. An engraving is first made upon soft steel, which is hardened by a peculiar process without in the least injuring its delicacy. A cylinder of soft steel, pressed with great force against the hardened steel engraving, is now made to roll very slowly backward and forward over it, thus receiving the design, but in relief. The cylinder is in its turn hardened without injury, and if it be slowly rolled to and fro with strong pressure on successive plates of copper, it will imprint on 1,000 of them a perfect facsimile of the original steel engraving from which it was made. Thus the number of copies producible from the same design may be multiplied 1,000-fold. But even this is very far short of the limits to which the process may be extended. The hardened steel roller, bearing the design upon it in relief, may be employed to make a few of its first impressions upon plates of soft steel, and these being hardened become the representatives of the original engraving, and may in their turn be made the parents of other rollers, each generating copper plates like their prototype. The possible extent to which facsimiles of one original engraving may thus be multiplied, almost confounds the imagination, and appears to be for all practical purposes unlimited. This beautiful art was first proposed by Mr. Perkins for the purpose of rendering the forgery of banknotes a matter of great difficulty, and there are two principles which peculiarly adapt it to that object. First, the perfect identity of all the impressions, so that any variation in the minutest line would at once cause detection. Secondly, that the original plates may be formed by the united labors of several artists most eminent in their respective departments, for as only one original of each design is necessary, the expense, even of the most elaborate engraving, will be trifling, compared with the multitude of copies produced from it. 125. It must, however, be admitted that the principle of copying itself furnishes an expedient for imitating any engraving or printed pattern, however complicated, and thus presents a difficulty which none of the schemes devised for the prevention of forgery appear to have yet effectually obviated. In attempting to imitate the most perfect banknote, the first process would be to place it with the printed side downwards upon a stone or other substance, on which, by passing it through a rolling press, it might be firmly fixed. The next object would be to discover some solvent which should dissolve the paper, but neither affect the printing ink, nor injure the stone or substance to which it is attached. Water does not seem to do this effectually, and perhaps weak alkaline or acid solutions would be tried. If, however, this could be fully accomplished, and if a stone or other substance, used to retain the impression, had those properties which enabled us to print from it, innumerable facsimiles of the note might obviously be made, and the imitation would be complete. Porcelain biscuit, which has recently been used with a black lead pencil for memorandum books, seems in some measure adapted for such trials, since its porosity may be diminished to any required extent by regulating the dilution of the glazing. 126. Gold and silver molding. Many of the moldings used by jewelers consist of thin slips of metal, which have received their form by passing between steel rollers, on which the pattern is embossed or engraved, thus taking a succession of copies of the devices intended. 127. Ornamental papers. Sheets of paper colored or covered with gold or silver leaf, and embossed with various patterns, are used for covering books, and for many ornamental purposes. The figures upon these are produced by the same process, that of passing the sheets of paper between engraved rollers. Of copying by stamping. 128. This mode of copying is extensively employed in the arts. It is generally executed by means of large presses worked with a screw and heavy flywheel. The materials on which the copies are impressed are most frequently metals, and the process is sometimes executed when they are hot, and in one case when the metal is in the state between solidity and fluidity. 129. Coins and medals. The whole of the coins which circulate as money are produced by this mode of copying. The screw presses are either worked by manual labor, by water, or by steam power. The mint which was sent a few years since to Calcutta was capable of coining 200,000 pieces a day. Medals, which usually have their figures in higher relief than coins, are produced by similar means, but a single blow is rarely sufficient to bring them to perfection, and the compression of the metal which arises from the first blow renders it too hard to receive many subsequent blows without injury to the die. It is therefore, after being struck, removed to a furnace, in which it is carefully heated red hot and annealed, after which operation it is again placed between the dies, and receives additional blows. For metals, on which the figures are very prominent, these processes must be repeated many times. One of the largest metals hitherto struck underwent them nearly 100 times before it was completed. 130. Ornaments for military accoutrements and furniture. These are usually of brass, and are stamped up out of solid or sheet brass by placing it between dies, and allowing the heavy weight to drop upon the upper die from a height of from 5 to 15 feet. 131. Buttons and nail heads. Buttons embossed with crests or other devices are produced by the same means, and some of those which are plain receive their hemispherical form from the dies in which they are struck. The heads of several kinds of nails which are portions of spheres, or polyhedrons, are also formed by these means. 132. Of a process for copying, called in France cliquet. This curious method of copying by stamping is applied to metals, and in some cases to forming stereotype plates. There exists a range of temperature previous to the melting point of several of the alloys of lead, tin, and antimony, in which the compound is neither solid, nor yet fluid. In this kind of pasty state it is placed in a box under a die, which descends upon it with considerable force. The blow drives the metal into the finest lines of the die, and the coldness of the latter immediately solidifies the whole mass. A quantity of the half-melted metal is scattered in all directions by the blow, and is retained by the sides of the box in which the process is carried on. The work thus produced is admirable for its sharpness, but has not the finished form of a piece just leaving the coining press. The sides are ragged, and it must be trimmed, and its thickness equalized in the lathe. Of copying by punching. 133. This mode of copying consists in driving the steel punch through the substance to be cut, either by a blow or by pressure. In some cases the object is to copy the aperture, and the substance separated from the plate is rejected. In other cases the small pieces cut out are the objects of the workman's labor. 134. Punching iron plate for boilers. The steel punch used for this purpose is from 3/8 to 3/4 of an inch in diameter, and drives out the circular disc from a plate of iron from 1/4 to 5/8 of an inch thick. 135. Punching tinned iron. The ornamental patterns of open work which decorate the tin and Japan wares in general use, are rarely punched by the workman who makes them. In London the art of punching out these patterns in screw presses is carried on as a separate trade, and large quantities of sheet tin are thus perforated for cutlenders, wine strainers, borders of waiters, and other similar purposes. The perfection and the precision to which the art has been carried are remarkable. Sheets of copper, too, are punched with small holes about the 1/100th of an inch in diameter, in such multitudes that more of the sheet metal is removed than remains behind, and plates of tin have been perforated with above 3,000 holes in each square inch. 136. The inlaid plates of brass and rosewood, called Gilt work, which ornament our furniture, are, in some instances, formed by punching, but in this case, both the parts cut out, and those which remain, are in many cases employed. In the remaining illustrations of the art of copying by punching, the part made use of is that which is punched out. 137. Cards for guns. The substitution of a circular disc of thin card instead of paper, for retaining in its place the charge of a fowling piece, is attended with considerable advantage. It would, however, be of little avail, unless an easy method was contrived of producing an unlimited number of cards, each exactly fitting the bore of the barrel. The small steel tool used for this purpose cuts out innumerable circles similar to its cutting end, each of which precisely fills the barrel for which it was designed. 138. Ornaments of gilt paper. The golden stars, leaves, and other devices, sold in shops for the purpose of ornamenting articles made of paper and pasteboard, and other fancy works, are cut by punches of various forms out of sheets of gilt paper. 139. Steel chains. The chain used in connecting the mainspring and fusee in watches and clocks, is composed of small pieces of sheet steel, and it is of great importance that each of these pieces should be of exactly the same size. The links are of two sorts, one of them consisting of a single oblong piece of steel with two holes in it, and the other formed by connecting two of the same pieces of steel, placed parallel to each other, and at a small distance apart, by two rivets. The two kinds of links occur alternately in the chain, each end of the single pieces being placed between the ends of two others, and connected with them by a rivet passing through all three. If the rivet holes in the pieces for the double links are not precisely at equal distances, the chain will not be straight, and will, consequently, be unfit for its purpose. Copying with elongation. 140. In this species of copying there exists but little resemblance between the copy and the original. It is the cross-section only of the thing produced which is similar to the tool through which it passes. When the substances to be operated upon are hard, they must frequently pass in succession through several holes, and it is in some cases necessary to anneal them at intervals. 141. Wire drawing. The metal to be converted into wire is made of a cylindrical form, and drawn forcibly through circular holes in plates of steel. At each passage it becomes smaller, and, when finished, its section at any point is a precise copy of the last hole through which it passed. Upon the larger kinds of wire, fine lines may sometimes be traced, running longitudinally. These arise from slight imperfections in the holes of the draw plates. For many purposes of the arts, wire, the section of which is square or half round, is required. The same method of making it is pursued, except that the holes through which it is drawn are in such cases themselves square, or half round, or of whatever other form a wire is required to be. A species of wire is made, the section of which resembles a star with from 6 to 12 rays. This is called pinion wire, and is used by the clock makers. They file away all the rays from a short piece, except from about half an inch near one end. This becomes a pinion for a clock, and the leaves or teeth are already burnished and finished, from having passed through the draw plate. 142. Tube drawing. The art of forming tubes of uniform diameter is nearly similar in its mode of execution to wire drawing. The sheet brass is bent round and soldered so as to form a hollow cylinder, and if the diameter outside is that which is required to be uniform, it is drawn through a succession of holes, as in wire drawing. If the inside diameter is to be uniform, a succession of steel cylinders, called triplets, are drawn through the brass tube. In making tubes for telescopes, it is necessary that both the inside and outside should be uniform. The steel triplet, therefore, is first passed into the tube, which is then drawn through a succession of holes, until the outside diameter is reduced to the required size. The metal of which the tube is formed is condensed between these holes and the steel cylinder within, and when the latter is withdrawn the internal surface appears polished. The brass tube is considerably extended by this process, sometimes even to double its first length. 143. Leaden pipes. Leaden pipes for the conveyance of water were formerly made by casting, but it has been found that they can be made both cheaper and better by drawing them through holes in the manner last described. A cylinder of lead, of 5 or 6 inches in diameter and about 2 feet long, is cast with a small hole through its axis, and an iron triplet of about 15 feet in length is forced into the hole. It is then drawn through a series of holes, until the lead is extended upon the triplet from one end to the other, and is of the proper thickness in proportion to the size of the pipe. 144. Iron rolling. When cylinders of iron of greater thickness than wire are required, they are formed by passing wrought iron between rollers, each of which has sunk in it a semi-cylindrical groove, and as such rollers rarely touch accurately, the longitudinal line will usually be observed in the cylinders so manufactured. Bar iron is thus shaped into all the various forms of round, square, half-round, oval, etc. in which it occurs in commerce. A particular species of molding is thus made, which resembles, in its section, that part of the frame of a window which separates two adjacent panes of glass. Being much stronger than wood, it can be considerably reduced in thickness, and consequently offers less obstruction to the light. It is much used for skylights. 145. It is sometimes required that the iron thus produced should not be of uniform thickness throughout. This is the case in bars for railroads, where greater depth is required towards the middle of the rail, which is at the greatest distance from the supports. This form is produced by cutting the groove in the rollers deeper at those parts where additional strength is required, so that the hollow which surrounds the roller would, if it could be unwound, be a mold of the shape the iron is intended to fit. 146. Vermicelli. The various forms into which this paste is made are given by forcing it through holes in tin plate. It passes through them, and appears on the other side in long strings. The cook makes use of the same method in preparing butter and ornamental pastry for the table, and the confectioner in forming cylindrical lozenges of various composition. Of copying with altered dimensions. 147. Of the pentagraph. This mode of copying is chiefly used for drawings or maps. The instrument is simple, and, although usually employed in reducing, is capable of enlarging the size of the copy. An automaton figure, exhibited in London a short time since, which drew profiles of its visitors, was regulated by a mechanism on this principle. The small aperture in the wall, opposite the seat in which the person is placed whose profile is taken, conceals a camera lucida, which is placed in an adjoining apartment, and an assistant, by moving the point, connected by a pentagraph with the hand of the automaton, over the outline of the head, causes the figure to trace a corresponding profile. 148. By turning. The art of turning might perhaps itself be classed amongst the arts of copying. The steel axis, called a mandrel, having a pulley attached to the middle of it, is supported at one end either by a conical point, or by a cylindrical collar, and at the other end by another collar, through which it passes. The extremity which projects beyond this last collar is formed into a screw, by which various instruments, called chucks, can be attached to it. These chucks are intended to hold the various materials to be submitted to the operation of turning, and have a great variety of forms. The mandrel with the chuck is made to revolve by a strap which passes over the pulley that is attached to it, and likewise over a larger wheel moved either by the foot, or by its connection with steam or water power. All work which is executed on a mandrel partakes in some measure of the irregularities in the form of that mandrel, and the perfect circularity of section which ought to exist in every part of the work, can only be ensured by an equal accuracy in the mandrel and its collar. 149. Rose engine turning. This elegant art depends in a great measure on copying. Circular plates of metal called rosettes, having various indentations on the surfaces and edges, are fixed on the mandrel, which admits of a movement either endwise or laterally, a fixed obstacle called the touch, against which the rosettes are pressed by a spring, obliges the mandrel to follow their indentations, and thus causes the cutting tool to trace out the same pattern on the work. The distance of the cutting tool from the center being usually less than the radius of the rosette, causes the copy to be much diminished. 150. Copying dies. A lathe has been long known in France, and recently been used at the English Mint for copying dies. A blunt point is carried by a very slow spiral movement successively over every part of the die to be copied, and is pressed by a weight into all the cavities, while a cutting point connected with it by the machine traverses the face of a piece of soft steel, in which it cuts the device of the original die on the same or on a diminished scale. The degree of excellence of the copy increases in proportion as it is smaller than the original. The die of a crown piece will furnish by copy a very tolerable die for a sixpence. but the chief use to be expected from this lathe is to prepare all the coarser parts, and leave only the finer and more expressive lines for the skill and genius of the artist. 151. Shoe last making engine. An instrument not very unlike in principle was proposed for the purpose of making shoe lasts. The pattern last of a shoe for the right foot was placed in one part of the apparatus, and when the machine was moved, two pieces of wood, placed in another part which had been previously adjusted by screws, were cut into lasts greater or less than the original, as was desired, and although the pattern was for the right foot, one of the lasts was for the left, an effect which was produced by merely interposing the wheel which reversed the motion between the two pieces of wood to be cut into lasts. 152. Engine for copying busts. Many years since, the late Mr. Watt amused himself with constructing an engine to produce copies of busts or statues, either of the same size as the original, or in a diminished proportion. The substances on which they operated were various, and some of the results were shown to his friends, but the mechanism by which they were made has never been described. More recently, Mr. Hawkins, who, nearly at the same time, had also contrived a similar machine, has placed it in the hands of an artist, who has made copies in ivory from a variety of busts. The art of multiplying in different sizes the figures of the sculptor, aided by that of rendering their acquisition cheap through the art of casting, promises to give additional value to his productions, and to diffuse more widely the pleasure arising from their possession. 153. Screw cutting. When this operation is performed in the lathe by means of a screw upon the mantle, it is essentially an art of copying, but it is only the number of threads in a given length which is copied, the form of the thread, and length as well as the diameter of the screw to be cut, are entirely independent of those from which the copy is made. There is another method of cutting screws in a lathe by means of one pattern screw, which, being connected by wheels with a mantle, guides the cutting point. In this process, unless the time of revolution of the mantle is the same as that of the screw which guides the cutting point, the number of threads in a given length will be different. If the mandrel move quicker than the cutting point, the screw which is produced will be finer than the original. If it moves slower, the copy will be more coarse than the original. The screw thus generated may be finer or coarser, it may be larger or smaller in diameter, it may have the same or a greater number of threads than that from which it is copied, yet all the defects which exist in the original will be accurately transmitted, under the modified circumstances, to every individual generated from it. 154. Printing from copper plates with altered dimensions. Some very singular specimens of an art of copying, not yet made public, were brought from Paris a few years since. The watchmaker in that city, of the name of Ganord, had contrived a method by which he could take from the same copper plate impressions of different sizes, either larger or smaller than the original design. Having procured 4 impressions of a parrot, surrounded by a circle, executed in this manner, I showed them to the late Mr. Lowry, an engraver equally distinguished for his skill, and for the many mechanical contrivances with which he enriched his art. The relative dimensions of the several impressions were 5.5, 6.3, 8.4, 15.0, so that the largest was nearly 3 times the linear size of the smallest, and Mr. Lowry assured me that he was unable to detect any lines in one which had not corresponding lines in the others. There appeared to be a difference in the quantity of ink, but none in the traces of the engraving, and, from the general appearance, it was conjectured that the largest but one was the original impression from the copper plate. The means by which this singular operation was executed have not been published, but 2 conjectures were formed at the time which merit notice. It was supposed that the artist was in possession of some method of transferring the ink from the lines of a copper plate to the surface of some fluid, and of retransferring the impression from the fluid to paper. If this could be accomplished, the print would, in the first instance, be of exactly the same size as the copper from which it was derived, but if the fluid were contained in a vessel having the form of an inverted cone, with a small aperture at the bottom, the liquid might be lowered or raised in the vessel by gradual abstraction or addition through the apex of the cone. In this case, the surface to which the printing ink adhered would diminish or enlarge, and in this altered state the impression might be retransferred to paper. It must be admitted that this conjectural explanation is liable to very considerable difficulties, for, Although the converse operation of taking an impression from a liquid surface has a parallel in the art of marbling paper, the possibility of transferring the ink from the copper to the fluid requires to be proved. Another and more plausible explanation is founded on the elastic nature of the compound of glue and treacle, the substance already in use in transferring engravings to earthenware. It is conjectured that an impression from the copper plate is taken upon a large sheet of this composition, that this sheet is then stretched in both directions, and that the ink thus expanded is transferred to paper. If the copy is required to be smaller than the original, the elastic substance must first be stretched, and then receive the impression from the copper plate. On removing the tension it will contract, and thus reduce the size of the design. It is possible that one transfer may not in all cases suffice, as the extensibility of the composition of glue and treacle, although considerable, is still limited. Perhaps sheets of India rubber of uniform texture and thickness may be found to answer better than this composition, or possibly the ink might be transferred from the copper plate to the surface of a bottle of this gum, which bottle might, after being expanded by forcing air into it, give up the enlarged impression to paper. As it would require considerable time to produce impressions in this manner, and there might arise some difficulty in making them all of precisely the same size, the process might be rendered more certain and expeditious by performing that part of the operation which depends on the enlargement or diminution of the design only once, and, instead of printing from the soft substance, transferring the design from it to stone. Thus a considerable portion of the work would be reduced to an art already well known, that of lithography. This idea receives some confirmation from the fact that in another set of specimens, consisting of a map of St. Petersburg, of several sizes, a very short line, evidently an accidental defect, occurs in all the impressions of one particular size, but not in any of a different size. 155. Machine to produce engraving from metals. An instrument was contrived, a long time ago, and is described in the Manual D. Turner, by which copper plate engravings are produced from metals and other objects in relief. The metal and the copper are fixed onto sliding plates at right angles to each other, so connected that, when the plate on which the metal is fixed is raised vertically by a screw, the slide holding the copper plate is advanced by an equal quantity in the horizontal direction. The metal is fixed on the vertical slide with its face towards the copper plate, and a little above it. A bar, terminating at one end in a tracing point, and at the other in a short arm, at right angles to the bar, and holding a diamond point, is placed horizontally above the copper, so that the tracing point shall touch the metal to which the bar is perpendicular, and the diamond point shall touch the copper plate to which the arm is perpendicular. Under this arrangement, the bar being supposed to move parallel to itself, and consequently to the copper, if the tracing point pass over a flat part of the metal, the diamond point will draw a straight line of equal length upon the copper, but, if the tracing point pass over any projecting part of the metal, the deviation from the straight line by the diamond point will be exactly equal to the elevation of the corresponding point of the metal above the rest of the surface. Thus, by the transit of this tracing point over any line upon the metal, the diamond will draw upon the copper a section of the metal through that line. The screw is attached to the apparatus, so that if the metal be raised a very small quantity by the screw, the copper plate will be advanced by the same quantity, and thus the new line of section may be drawn, and, by continuing this process, the series of sectional lines on the copper produces the representation of the metal on a plane, the outline and the form of the figure arising from the sinuosities of the lines, and from their greater or less proximity. The effect of this kind of engraving is very striking, and in some specimens gives a high degree of apparent relief. It has been practiced on plate glass, and is then additionally curious from the circumstance of the fine lines traced by the diamond being invisible, except in certain lights. From this description, it will have been seen that the engraving on copper must be distorted, that is to say, that the projection on the copper cannot be the same as that which arises from a perpendicular projection of each point of the metal upon a plane parallel to itself. The position of the prominent parts will be more altered than that of the less elevated, and the greater the relief of the metal the more distorted will be its engraved representation. Mr. John Bate, son of Mr. Bate, of the Poultry, has contrived an improved machine, for which he has taken a patent, in which this source of distortion is remedied. The head, in the title page of the present volume, is copied from a medal of Roger Bacon, which forms one of a series of medals of eminent men, struck at the Royal Mint at Munich, and is the first of the published productions of this new art. 3 * The inconvenience which arises from too high relief in the mede, or in the bust, might be remedied by some mechanical contrivance, by which the deviation of the diamond point from the right line which it would describe when the tracing point traverses a plane would be made proportional not to the elevation of the corresponding point above the plane of the mede, but to its elevation above some other parallel plane removed to a fit distance behind it. Thus busts and statues might be reduced to any required degree of relief. 156. The machine just described naturally suggests other views which seem to deserve some consideration, and, perhaps, some experiment. If a mede were placed under the tracing point of a pentagraph, an engraving tool substituted for the pencil, and a copper plate in the place of the paper, and if, by some mechanism, the tracing point, which slides in the vertical plane, could, as it is carried over the different elevations of the mede, increase or diminish the depth of the engraved line proportionally to the actual height of the corresponding point on the mede, then an engraving would be produced, free at least from any distortion, although it might be liable to objections of a different kind. If, by any similar contrivance, instead of lines, we could make on each point of the copper a dot, varying in size or depth with the altitude of the corresponding point of the metal above its plane, then a new species of engraving would be produced, and the variety of these might again be increased, by causing the graving point to describe very small circles, of diameters, varying with the height of the point on the metal above a given plane, or by making the graving tool consist of 3 equidistant points, whose distance increased or diminished according to some determinate law, dependent on the elevation of the point represented above the plane of the mede. It would, perhaps, be difficult to imagine the effects of some of these kinds of engraving, but they would all possess, in common, the property of being projections, by parallel lines, of the objects represented, and the intensity of the shade of the ink would either vary according to some function of the distance of the point represented from some given plane, or it would be a little modified by the distances from the same plane of a few of the immediately contiguous points. 157. The system of shading maps by means of lines of equal altitude above the sea bears some analogy to this mode of representing metals, and if applied to them would produce a different species of engraved resemblance. The projections on the plane of the mede, of the section of an imaginary plane, placed at successive distances above it, with the mede itself, would produce a likeness of the figure on the mede, in which all the inclined parts of it would be dark in proportion to their inclination. Other species of engraving might be conceived by substituting, instead of the imaginary plane, an imaginary sphere or other solid, intersecting the figure in the mede. 158. Lace made by caterpillars. The most extraordinary species of manufacture, which is in a slight degree connected with copying, has been contrived by an officer of engineers residing at Munich. It consists of lace, and veils, with open patterns in them, made entirely by caterpillars. The following is the mode of proceeding adopted. He makes a paste of the leaves of the plant, which is the usual food of the species of caterpillar for * he employs, and spreads it thinly over a stone, or other flat substance. He then, with a camel hair pencil dipped in olive oil, draws upon the coating of paste the pattern he wishes the insects to leave open. This stone is then placed in an inclined position, and a number of the caterpillars are placed at the bottom. A peculiar species is chosen, which spins a strong web, and the animals commencing at the bottom, eat and spin their way up to the top, carefully avoiding every part touched by the oil, but devouring all the rest of the paste. The extreme lightness of these veils, combined with some strength, is truly surprising. One of them, measuring 26½ inches by 17 inches, weighed only 1.51 grains, the degree of lightness which will appear more strongly by contrast with other fabrics. 1 square yard of the substance of which these veils are made weighs 4 1/3 grains, whilst 1 square yard of silk gauze weighs 137 grains, and 1 square yard of the finest patent net weighs 262½ grains. The ladies' colored muslin dresses, mentioned in the table subjoined, cost 10 shillings per dress, and each weigh 6 ounces, the cotton from which they are made weighing nearly 6 2/9 ounces avoirdupois weight. Weight of 1 square yard of each of the following articles. 5 asterisk. Weight of way cotton used, value finished of in waking per yard. 1 square description of goods, measure yard. SD. Troy grains. Caterpillar veils, 4 1/3, silk gauze 3 to 4 wide 137, finest patent net, 262 1/2, fine cambric muslin, 551, 640 HS jaconet muslin 20613-670 ladies colored muslin dresses 3078885 640 HS cambric 1297-10699 DHS calico 0998810851 1/2 yard nankeen 0820-402432 159. This enumeration, which is far from complete, of the arts in which copying is the foundation, may be terminated with an example which has long been under the eye of the reader, although few, perhaps, are aware of the number of repeated copyings of which these very pages are the subject. 1. They are copies, by printing, from stereotype plates. 2. These stereotype plates are copied, by the art of casting, from molds formed of plaster of Paris. 3. These molds are themselves copied by casting the plaster in a liquid state upon the movable types set up by the compositor. It is here that the union of the intellectual and the mechanical departments takes place. The mysteries, however, of an author's copying, form no part of our inquiry, although it may be fairly remarked, that, in numerous instances, the mental art eclipses the mechanical copyist. For these movable types, the obedient messengers of the most opposite thoughts, the most conflicting theories, are themselves copies by casting from molds of copper called matrices. 5. The lower part of those matrices, bearing the impressions of the letters or characters, are copies, by punching, from steel punches on which the same characters exist in relief. 6. These steel punches are not themselves entirely exempted from the great principle of art. Many of the cavities which exist in them, such as those in the middle of the punches for the letters A, B, D, E, G, etc., are produced from other steel punches in which these parts are in relief. We have thus traced through 6 successive stages of copying the mechanical art of printing from stereotype plates, the principle of copying contributing in this, as in every other department of manufacture, to the uniformity and the cheapness of the work produced. Notes. 1. The late Mr. Lowry. 2. I possess a lithographic reprint of a page of a table, which appears, from the type, to have been several years old. 3. The construction of the engraving becomes evident on examining it with a lens of sufficient power to show the continuity of the lines. 4. The Falanas partilla, which feeds on the prunus pages. 5. Some of these weights and measures are calculated from a statement in the report of the Committee of the House of Commons on Printed Cotton Goods, and the widths of the pieces there given are presumed to be the real widths, not those by which they are called in the retail shops.